Hey everybody, Mr. Jones here. Today we're going to go over the model of SALT lab. The lab has been posted in your Google Classroom so you can get to the document by that. But before you go to the document, we're going to need a few items so you can complete this lab. The first thing you're going to need are toothpicks. So ask an adult to run out and buy some toothpicks because you're going to need them for this science lab. The other thing you're going to need, the lab says clay. But if you don't have clay, go out and buy some Mike and Ike's, some gummy bears. Go buy some soft candy that's all the same shape, and you're gonna need at least 2 colors. So before you begin this lab, make sure first, you've got toothpicks. Second, you've got either different colored clay, Play-Doh, gummy bears, Mike and Ike's, anything like that. And then third, make sure you print off the document or you have the document open so that you can follow along. Now, before we move on, I want to give you some background information. And I've built a Prezi, so right now, if you're looking at that Prezi, click into the background information. So if you're looking at the background information now, you'll see that salt is made of sodium and chlorine, NaCl. Sodium, if we look at the periodic table, sodium has 1 electron in its outer shell. Chlorine has 7 electrons in its outer shell. Now remember when we were doing work with valence electrons, elements that are balanced want to have 8 total electrons. Now sodium, having 1, doesn't really want it. Sodium likes to give it away. Because of that, sodium becomes what we call an ion, or a positively or negatively charged element. So if you think about it, and we have sodium. Sodium, and if we do the dot diagram, sodium has 1 electron. It doesn't really want 1. It can't do much with 1. It can't really bond. So it likes to give that 1 electron away, and it gives it to chlorine. And chlorine has 7. So sodium has 1 electron in its outer shell. Chlorine has 7. Sodium wants to give an electron away, and when it does, it gives away a minus. Now, sodium is the 11th atom on the periodic table, the 11th element, which means it has 11 pluses, 11 protons. If it gives away one of its electrons, it's got 11 pluses and 10 minuses. So sodium becomes positively charged. Chlorine takes an extra minus and it becomes negatively charged. And see, you've got a plus and a minus. And if you have +1, -1, they're balanced. So when sodium and chlorine bond, they form a balanced equation. You have +1, you have -1, together they have zeros. So you've got your electrons and sodium bonds. When they bond like this and one gives one away or becomes positively or negatively charged, and the other element becomes positively or negatively charged, we call that an ionic bond. So salt has an ionic bond. Now the interesting thing, certain elements, when you add them together, they form a crystal lattice or a 3-dimensional arrangement that the crystals always take the form of. I really kind of like this because as a geologist, when I was collecting rocks and specimens, we would come across rocks and specimens that have all, if you look at these crystals, they're all the same shape. And it's because of the crystal lattice. The atoms inside of this sand crystal all arrange in the exact same formation, the same pattern. And because of that, each of the crystals looks identical. Another example to that is quartz. Quartz, you can have a huge quartz crystal, and it's got the square sides and everything. You can have little tiny blue or clear quartz crystals, and they've got all the same shape. Or you can have an entire plate of different quartz crystals. and they all have the same shape. And that is because of its crystal lattice. Now, salt, whether it's table salt or salt from the ocean or salt from the salt flats, table salt, if you were going to take some of this and you were to sprinkle it on a microscope and look at it, salt all has the exact same shape. All salt bonds in a cubic form, or it makes a cube, a four-sided, all the same measurement cube. We're going to check that out next. So let's go over to the procedure. Hopefully you have the items you need. Before you click into procedure, make sure you've got your toothpicks and make sure you've got your items that you're going to use for atoms. Now for me, I happen to have some clay, so I'm going to use clay like the directions say. It says to choose red for sodium, so I've got some red clay for sodium, and blue for chlorine. So I've got some blue for chlorine. Here's my sodium, my chlorine. What you're going to do is you're going to start bonding these together. Now remember, sodium has 1 electron, so it likes to bond with chlorine because chlorine has 7, and together they have 8 electrons and they're happy. But if this sodium bonds with this chlorine, then this sodium can bond with this chlorine. And then if this chlorine and this chlorine, they need to bond, they bond with another sodium. And what happens is you put your bonds together and it makes a square. So you've got a sodium bonded with a chlorine, a sodium bonded with a chlorine, a sodium bonded with a chlorine here or a chlorine there. You get a square. So here, I'll stick it to the board, is our first sodium chloride or salt molecule. Now, you're going to need to make 4 or 5 of these layers. So I showed you how to do one. Now, using whatever supplies you've got and the 2 colors, red for sodium, blue for chlorine, bond them together that make a square. Do this at least 4 times. So do that now, and I am going to continue to make some here. Each one of the toothpicks that you stick in represents a bond. So each toothpick between all of your molecules, that is 1 ionic bond. So right there, I've got another crystal. Now you'll notice some of these are not perfectly square, and that's okay, they don't need to be. They just gotta look like good enough like squares with your sodium and your chlorine bonded, and your sodium and your chlorine, and your chlorine and your sodium, and your sodium, and your chlorine. So there I've got 3 that are done. Go, and I'm gonna do one more just so that we've got a set of 4. Once you have completed at a minimum at least 4 of these models, you are now going to step 4 and step 5. You are going to build your model so it's 3-dimensional. Right now, if you look at the ones on the board, they're all flat. This is 2-dimensional. It's not a 3-dimensional model. And able to make it 3-dimensional, it's got to grow. It's got to be more than flat. So you got your 4 or 5 samples. Now you're going to make a larger model by connecting these. So if we've got 1 sodium chlorine here, and we've got another sodium and chlorine here, you know obviously this chlorine is going to bond with one of these sodiums. So we can connect them. And when we connect them, we just add these bonds and we make a three-dimensional model. So I'm going to connect two of these things together so you can take a look. Now I've got one three-dimensional example of salt. I've got sodium bonded with chlorine, sodium bonded with chlorine, sodium bonded with chlorine. You can turn it, sodium bonded with chlorine, sodium, all the way around. Every sodium molecule is bonded with chlorine. Keep building onto it. Keep making, I've got two more structures. We're gonna add those to it as well. So this is your steps 4 and 5. And each time you just make sure when you're bonding your sodiums and chlorines together that they specifically go with what they belong, the sodiums and the chlorines. When you are done, you are gonna have a three-dimensional model. Since you made 4, at a minimum 4 squares, you're gonna have a fairly good sized three-dimensional model. Mine is all put together now. Check it out. I know it's not straight and it's not perfect, but if you look, sodium and chlorine, sodium and chlorine, sodium and chlorine. On the end, sodium and chlorine. On the underneath, sodium and chlorine. On the back, all of them are the same. So here is a three-dimensional model of salt. Now let's go on to the final part, which is analysis. There are 3 questions you need to answer. So click into analysis. The first question, why is it important to not connect 2 sodiums together or 2 chlorines? So think about it. Why would this not work? Now, when you're thinking about that answer, think about words like positive charge, negative charge, ionic bonds. Why can't you take chlorine and chlorine and bond them together, or sodium and sodium? Think about the electrons. Think about wanting 8 and being balanced. Why does this not work, but this works perfect? So your second question, describe the repeating pattern of ions in the model you built. Remember, your ions are 1 sodium and 1 chlorine. So describe the pattern that happens. Every sodium has got to be bonded with a chlorine. Every chlorine has to be bonded with a sodium. When that happens, they form a very specific shape. They form a crystal lattice and structure. Describe this for question 2. And then finally, for question number 3, how did the shape of the individual models, how does this shape affect the shape of your final model? Compare them and contrast them. How does this affect this? So that is the model of Salt Lab. And able to complete it, you're going to need to get toothpicks. You're going to need to get some items that are going to represent your sodium atoms and your chlorine atoms. Go through this step by step. Use this video to help. Check out the questions. Make sure you answer them, and good luck, everybody. Have a great day.